Good morning, student. I am a Professor Thorat N N, Assistant Professor in Information Technology in JSPM Bhurabai Sawant Institute of Technology and Research, Phule Pune. So today I will explain practical session VIT subject CL7. So practical session, there are 4 practicals in this CL7 subject. So I will explain assignment number 1. That assignment number 1, write a program in C++ or Java to implement RSA key generation and cipher verification. So in this assignment number 1, we implement the Java program, C++ program, and generate the 2 keys, private and public key, for convert the encryption and decryption purpose. So objective of this assignment number 1 is that to study the basic concept of RSA and process. What is the main objective of this assignment number 1? To study the basic concept of RSA and process of algorithm. And after completion of this assignment number 1, student understand the implementation and the RSA algorithm. Right. So these are the outcome of the assignment number 1. So what is the theory of RSA? RSA is one algorithm. That algorithm is developed by 3 scientists, Ravesh, Samir, and Edelman. That's why this name of this algorithm is RSA algorithm. Ravesh, Samir, Edelman, these are the scientists. They developed this algorithm in 1978. So why it is developed? Because this algorithm used for the whatever message, that message is encrypt and decrypt purpose. So use of this algorithm is that encryption and decryption first. But RSA algorithm, we first generate the 2 keys, public and private key, and after that we encrypt the message and decrypt the message. So what is the encryption decryption? So encryption and decryption means what? Whatever plain text message, that plain text message is converted into ciphertext, or readable format message is converted into unreadable format, that is called as a encryption. What is the decryption process? Decryption process means what? Whatever ciphertext message is converted into plain text message, that is called as a decryption. On unreadable format information is converted into readable format information, that is called as a decryption process. But encryption and decryption always uses 2 keys for the encryption and decryption. One is a public key and another is a private key. So RSA algorithm, encryption purpose use public key and decryption purpose use private key. All right. So this algorithm is also called as a public key cryptography because 2 different keys used for the encryption and decryption. One is a public key, another is a private key. So RSA algorithm involves 3 steps, right? Involve 3 steps. So this step is called as a key generation. Second one is a encryption and decryption. So what is the key generation? So key generation means what? Generate the 2 keys, private and public key. Public key used for the encryption and private key used for the decryption. Right. I will see this key generation algorithm in next slide number 4. And what is the encryption decryption? It is a process. It converts plain text to ciphertext, and ciphertext to plain text is called as the decryption. So in RSA algorithm, we implement this algorithm by using 2 prime numbers. That prime number is called as P and Q. Before going on this algorithm, we look out this diagram. In this diagram, this is a plain text. That plain text is converted into ciphertext, right? So by using public key, means plain text is converted to ciphertext here by using public key, and ciphertext is converted into plain text by using private key, right? So this is the encryption process and this is the decryption process. So in this algorithm, RSA algorithm, there are 2 prime number. By using this prime number, this algorithm is implemented, right? So select 2 prime number, that P and Q, compute n equal to P and Q. N is required for the public and private key. So n, how it is calculate n? By using P into Q, right? So P is the first prime number, Q is the second prime number, and we compute the n. N is used for the public and private key. Then compute pi value by using P minus 1 into Q minus 1. What is the P? P is a prime number. Minus 1 means prime value subtract from 1, and prime second value subtract from 1, and this value is called as a pi value. right? Then choose step number 4, E equal to 3. What is a E means what? Here we use one value, that value is for the public key. So GCD calculation, or check GCD is of this E minus P, E comma P minus 1 should be 1. Means E value is a 3, P minus 1 value is a consider any value, it should be a 1. Same for this one, same for the pi also. Next, fifth, compute the D such that D value is used for the decryption purpose here, or private key purpose, right? So D value, how it is calculated? D equal to 1 divided by E mod pi value, right? So E value, you know, this is a E value, right? What is a pi value? Pi value compute in a step number 3, and we got here D, right? After that, we got two keys. One is a public key and another is a private key. Public key used for the encryption and private key used for the decryption. So see here, public key equal to N comma E. N is a value. That value is already computed in a step number 2, and E is a choose E value equal to 3, means N comma E value is called as the public key. What is the private key? N value comma whatever value already calculated in a step number 5, that value is called as the D value, right? So after that, this is the encryption process. Now say that we want to encrypt the message. Message is considered M equal to nil or 7. This message, that message is converted into plain text into ciphertext, and that ciphertext converted into again plain text in a decryption process. So how it is calculated encryption process? By using formula C equal to M raised to E mod N. So C value means what? Encryption value. Here we got here encryption value by using this formula M raised to E mod N. So what is the M value? M means a message, raised to E means whatever value choose in a step number 4, that is E value, and mod N value is already calculated in second step. After that, we got here ciphertext. In 7 step we got ciphertext, and 8 we got here plain text again. To check decryption, we compute by using M dash equal to C raised to D mod N. Right. So mod C raised to D, C already calculated in 7 step. This is a C value that calculate in a 7 step, and D value already calculated in 5th step. Mod N value already compute in 2nd step, right? So whatever that message is again it converted into plain text, that is called as a decryption process. After that, stop. Next, RSA. This algorithm we explain in an example way. Select prime number P and Q. P value is 11, Q value is 3. N equal to PQ means P into Q. 11 into 3 equal to 33. Right? Means 11 is a prime number, 3 is a prime number, 33 is a product of 11 and 3, that is called as N number. Pi value equal to P minus 1, Q minus 1 equal to means P minus 1. P value is considered 11 here. Minus 1 means 10, 11 minus 1, 10, and 3 minus 1, 2. There's a product काय येणार आहे 20. Choose 3. Choose 3 केल्यानंतर काय होणार आहे? GCD E P minus 1, it should be always 1. Here. Check GCD E Q minus 1. Q minus means second PQ prime number minus 1, and we got here 1. Same for the pi value, that is also 1. Compute D such that ED equal to 1 mod pi. See here, compute D equal to 1 divided by E mod pi. 1 is a value that divided E. E is a value of 3. Value of E is 3. Mod pi value is already calculated in 20. Means 1 upon 3 mod 20. That is the value of the 7. That is used in a private key here. Same for the public key. Public key already calculated. N, what is the N? 33. And what is the E? Already choose in a step number 4. That is a 3. Private key already 33. N is a 33 here. And D value is already calculated in number 5. That public and private key used for the encryption and decryption process. So 7th step is that Now you can want to encrypt the message m equal to 7. This is a message that we convert into message into ciphertext, plain text into ciphertext. See here, c equal to m raised to e mod n. What is the c value? No, we calculate the c value here. So 7 is value, that 7 value is called as a m value. This is the m value. Raised to 3. Raised to 3 means what? This is a e value. E value is called as a 3. And mod 33 means 343 mod 33 equal to 30. This is a 7 converted into ciphertext 13. Hence, ciphertext c equal to 13. To check step number 8, to decrypt the process, compute decrypt by using m dash equal to c raised to d mod n. So what is the c value? You know what is the c value? C value here calculated 13. 13 raised to d, d value already calculated in step number 5, 7. Mod n, n is already calculated in second step 33. Right, means that 33 raised to 7 mod 33 equal to 7. Means we got here convert 7 into 13 and 13 into 7. Then stop. So this is RSA example. Then now we will proceed to RSA program implement and execute. Right. So student, first click on terminal button. Go to the terminal, right? Then here we use first whatever Ubuntu, that Ubuntu should be updated version. So write down first update your Ubuntu from using this command sudo apt get update. This window is this Ubuntu is already updated. I can't update this window. So press enter. After that, we enter the we use here gedit, that gedit use Parati to implement or to write a program, CPP program in your gedit. Gedit is an open source software. That software we install first here by using this command sudo apt get install gedit. This gedit is already installed in this machine, so I can't install this. After that, we open gedit. Here we can type gedit and then press enter. After that, one window is appear here. That window is called as a untitled window, and here we write the program. Before write the program, we save that program by using xyz.cpp program. So this is a RSA program. So I will assign the name xyz.cpp here. Right. Then save this program and here write down the program. So I will already write this program. So simple. I will copy here. So paste here and save this program again. So in this program, we store this, means write the three header file. That header file means IOStream, CMath, C Studio. So using this namespace std, this is a most important command. That command is used here. Then I will use here class RSA. In this class, we public means any can access this integer value, right? PQ, these are the prime numbers. N is a number that compute P into Q. T is a pi value. That pi value store in a T. Same for the E and D. This is a flag, is a temporary variable. E is a and D. E value is a 0 to 99. We can use here array. Same for the D, 0 to 99. This is a array. Then temporary variable, right? So this temporary variable, then I will use here. J is a temporary variable. M for the use for the message, and this is for the encryption, and use I string message. Though this is also used for the message purpose. So this is a function of RSA, long X, long Y, string S. Long X and long Y, these are the prime number, and string means message here. So long I use for the initialization of whatever that message we type. That message is initialized from 0 to length of the string. So P equal to X. This prime number is stored in X, Q number is stored in a Y, and the message is stored in a S. Then compute N equal to P into Q. N equal to P into Q. This is a first, second step, and then third step is T equal to P minus 1 into Q minus 1. The T value is called as a pi value, right? Then prime number, here check the whatever that prime number, that number is a prime number or not. Here check the prime number or not. Means whatever user enter the value, that value is prime or not. Here check by using square root function, and PR divided by I equal to 0. Then it check. If it is okay, then it select prime number. Then C and CD. These are the C and CD. It calculate the E and D value by using this function, right? Then here encryption and decryption. Here encryption and decryption. This is an encryption function. In this encryption function, we first enter the value of E. If it is E value, whatever that E value, we got the convert the encryption means plain text into ciphertext, and here enter the D value, then we got the ciphertext into plain text. But this all function are object is created in main function, right? So this is a enter the prime number P and Q, then scene means scan this value, then enter the message, which will be a convert into plain text into ciphertext. Then whatever possible value it display in your screen, E and D value, and choose any value of E and D you want to use for the encryption and decryption, and then we convert that plain text into ciphertext and ciphertext into plain text. Okay, so save this program. Then I will explain how it is run the program by using run your programming. Go to the first terminal, right? Then right, go to the terminal and then simply type G++ dot whatever program name, that program name xyz.cpp, right? So here compile first your program, then run your program by using ./a dot out. Here enter the two prime number. I will choose here 11 and 3, right? After that we enter the message. That message name is a Nilesh. We got the here possible value E and D. That possible value we choose here. That possible value I will choose here. Consider 1, serial number 1. Then we got here convert this Nilesh plain text message into ciphertext, and then ciphertext message into convert into plain text. Means here 7, this 7 value and 3 value. This 7 and 3 value is used for the E and D for the conversion of plain text to ciphertext and ciphertext to plain text. So this E value is a 7. See here 7, and 3 value is a D value, right? So this is a RSA program, right? So this is the output of your RSA program. You convert the plain text into ciphertext and ciphertext to plain text, or readable format into unreadable, or unreadable format into readable format, right? So thank you very much to listening me, right? So thank you very much.